Let's see the problem number 44 from test 2, and the topic is machine design. Okay, it's basically on ball bearings. Okay, so what is given is the dynamic load capacity for ball bearing is given 22 kilonewtons. Okay, the maximum radial load what it can sustain is asked, and the speed is 600 rpm, and it is run for 2000 hours. Okay, so let's see what is the life. It is, the total life in revolutions. It is run only for 2000 hours. So let's see how much revolution. So speed is 6000 revolutions per minute, and it is run for 2000 hours. So the total will be speed into time in minutes. Before we'll get the total revolution. So it will be 600 into 2000 hours into 60. This is 2000. So ultimately it will be 36 into 72. It will be 72 into 10 power 6 revolutions. Okay. Now the dynamic load capacity is basically related to the equivalent load into the life. Okay. And there's a factor 1/3. This comes for ball bearings. And why I say this is ball bearings is based on this number 6306. So this is a common designation nomenclature for ball bearings, where the last two digits can give you the diameter when you multiply with 5. Okay, so let's come back to this problem. So equivalent load, well, if I have the radial load as well as the axial thrust load, I can find out the radial load, but I can find out the equivalent load. But as in the problem, I have only the radial load, so the equivalent load is the radial load. And this life, remember in this expression, you need to keep this in millions of revolutions. Life in millions of revolutions. Okay. So C is given, which is 22 kilonewtons. This is asked, and the life has to be in millions of revolutions. So I have to divide it by 10 power 6, because 1 million revolution is 10 power 6 revolutions. So it is basically P radial into 72 1/3 22. So if I use the calculator, I'll be getting the answer as 5.29 kilonewtons D. Thank you.